Hello everyone. So today we're going to talk about spherical coordinate systems. Now, a spherical coordinate system is easily explained if you think about a sphere. So let's say I draw a ball, right? Now this ball, again, three-dimensional. I'm doing my best here to showcase that. Has an origin, which we will call the center of the ball, and again, that is we can just say that's O as our origin. Now imagine this ball has a radius of r. R can change back and forth. In spherical coordinates, we actually will call this, instead of r, we will call it rho. And next, after you've imagined this ball and imagined the radius r, imagine you have to pick a point on this ball, because every point on this ball is a radius of rho away from the center. So how do we know that I'm trying to distinguish, let's say, this point compared to this point over here? So there's two things that we have to consider here, which are the two angles that determine where the arrow is pointing. Firstly, if we think about this ball, think about the horizontal plane, which I can draw like this, where this is the center of the ball and this is just the plane, where this is like the horizontal plane that cuts in between. Now if I want to determine which direction I'm going in this horizontal plane, am I facing to the right, am I facing towards the back side of this, to the left, or towards you, you have to start from an axis or a starting point, which we can label here as the x-axis. Now from this x-axis, if we rotate a certain amount, so let's say we rotate over, we want to get to this point over here, we would have to rotate this all the way around until we are facing that point. We can call that angle phi. Angle phi is what we have to rotate from the positive x-axis to get to a certain point within the xy plane. Now to describe the other point, because not only will we be facing a direction that is going in the xy plane, but we also have to consider, is it going up, is it pointing down? So we have to consider which way it's going there. So next we can consider the other plane, which looks something like this, where we can call this up here the z-axis, and this is the zx plane. So if I were to draw the x here, it would look like this. This over here would be the xy plane, if I can draw this without messing up the picture. So here that we have the zx plane, this basically just tells us how much do I have to go up from the plane, the x-axis, to point towards my direction. Now again, this doesn't have to be the x-axis, it could also be the y-axis, but that really depends on how far we rotated. Let's say that we didn't rotate and we were facing in the x direction, then it would look something like this. But if we rotate 90 degrees and now we're facing in the y direction, this would be the zx plane. If we rotate a random amount, then this axis down here would just be that random amount. So once taking a look at this, we just want to see how far we have rotated down. So we take the z-axis up here to be positive, and so we look down a certain amount of degrees. So in this case, let's say that I take the z-axis and I want to go over here. So I would have to rotate down by theta degrees, that much. So with the combination of theta, phi, and rho, we can describe any point on the space. Theta and phi are used to determine the direction where we are pointing, and rho is used to determine how far away that point is. So as a rough example, which may not completely be accurate in numbers wise, let's say that we have in Cartesian coordinates we have the point 1, 1, 1. So we know this is going in the x direction by 1, the y direction by 1, and the z direction by 1. And where does that point lie? So let's actually draw it out. So we know this is our x-axis, our y-axis, and our z-axis in Cartesian coordinates. We go plus 1 in the x-axis, we go plus 1 in the y-axis, and then we go up 1 in the z-axis. So our point is somewhere about here. Now I know this picture looks a little weird, but I hope you can see that this is x, y, and z like that. So we moved 1 in every direction. Now how do we do this in spherical coordinates? So let's say, now that I have my spherical coordinates, I will write my x, y, z again. Now remember that the first thing we have to consider usually is the angles, right? So how much am I rotating by in the xy plane? We start from the positive x-axis, and we can see that since this is 1 in the x and 1 in the y, it's right in the center, so it kind of faces this way diagonally. So we're rotating from here, we're rotating 45 degrees. So one thing we know is that we know we're facing this way in the xy plane, because we know our point 1 and 1 in the x and the y will take us over here. So that rotation we will call theta, and that is equal to 45 degrees. Now the next one, oh sorry, that's actually our phi. I'll change that. So next thing we have to consider is from the z-axis, how far are we looking down to look at this point? Now I've chosen these coordinates so they are kind of symmetrical in some way. So what we have here is this distance, from the xy plane, we go up by 1, so we end up here, right? Now when we know that from the origin, if we draw an arrow to this point, it looks something like that. That point going straight up here should come down like this, if you can imagine it. So but that point is called our theta. So once we have how much we rotate in the xy plane, next we find out how much we come down in the z plane. Now I don't know what that angle is. I'm sure it's 45 degrees, but I don't want to be wrong, so I'm not going to write anything down. So we have our phi and our theta, and lastly we have here the distance that we have to come from the origin to this point directly, and that is called rho. Because you see, we could come from the origin and we could just keep going, right? We could be all the way over here. So that rho distance determines how far we actually go. Now this 1, 1, 1 is just Pythagorean theorem, so I know that that distance is root 3 if you use Pythagorean theorem. But in a spherical coordinate system, we have rho, phi, and theta, and we would write this as root 3, which is the distance that we travel, phi, which is how much we rotate in the xy plane. In this case it's 45 degrees, but in radians that is pi over 4, and theta is how much we've come down. Now in this case I don't know exactly what it is. It should be 45 degrees as well, but I will just write that as theta. So whatever number that is.